it is time to spend an entire video calculating this thing. By the way, if you're not sure what's going on at any point, I did make some previous videos with some good background information. So, actually I lied a little bit. I'm not going to do f omega squared, I'm going to do f omega squared plus 1, because the plus 1 really helps to bring out the power of the omega squared in this case. Now, this is a successor ordinal, right? It has an immediate predecessor, namely omega squared. So the input 3 tells me to repeat the function 3 times, but dropping the plus 1. And now let's focus just on, let's zoom into this part here next. Alright, so now I see that omega squared is a limit ordinal. Does not make sense to subtract 1 from this. It has no immediate predecessor. So that means I'm going to plug in 3 into the omega squared. At least that's how I'm going to use the English language to refer to it. So the fundamental sequence associated with omega squared is going to be this thing. You see it's strictly increasing, and omega squared is the least upper bound. This is omega squared of 0, omega squared of 1, omega squared of 2, omega squared of 3. Omega squared of 3 is omega times 3, so I replace the omega squared with the omega squared of 3, which is omega times 3. Now let's zoom into this part. I see that once again omega times 3 is a limit ordinal, so let's go ahead and plug 3 into it. Let's see, 0, 1, 2, 3. Omega 3 of 3 is going to be this thing, omega times 2 plus 3. So I'm going to go ahead and replace the omega times 3 with omega times 2 plus 3. And now I have a successor ordinal, so let's zoom in here. With our successor ordinal, I see that the input is 3, so I'm going to repeat the function 3 number of times, but with the power level dropped by 1, so the omega times 2 plus 3 becomes omega times 2 plus 2. Now we can zoom into this over here, and I see that this is also a successor ordinal, still with an input of 3, repeat it 3 times with the power level dropped by 1. Then I can zoom in here, which is right here, and I see that this is also a successor ordinal, so we'll repeat it 3 times because that's what the input is, and I drop the power level by 1 to get omega times 2 instead of omega times 2 plus 1. And how do we evaluate f sub omega times 2 of 3? Well, omega times 2 is a limit ordinal, so we'll go ahead and plug the 3 in there. Let's see, omega times 2 of 0, omega times 2 of 1, omega times 2 of 2, omega times 2 of 3. So I'm going to go ahead and replace the omega times 2 with this thing, which is the same as omega plus 3. So I get f sub omega plus 3 of 3. And omega plus 3 is a successor ordinal, so I'm going to go ahead and repeat the function 3 number of times with the power level dropped by 1 in each case. Now I'm going to zoom into this last part here. I see that omega plus 2 is a successor ordinal, so this part is going to get replaced with 3 copies of f omega plus 1 applied to 3. Then I'll zoom into this part at the end here, and it's going to get replaced with 3 copies of f omega applied to 3. And then zooming into the f omega of 3 at the end, I am going to see that omega is a limit ordinal, so I plug in the 3. Okay, let's go a little bit faster now. So omega of 3 is going to be 3, so this is going to become f sub 3 of 3. Now we have the ordinal number 3, which is a successor ordinal. It's in the form of alpha plus 1, namely, specifically, it's 2 plus 1. So I'm going to get 3 copies of f2. So f2, f2, and then that third f2 is going to expand out into 3 copies of f1, 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 and then the last f1 is going to expand out into 3 copies of f0. So this is the first copy of f2, this is the second copy of f2, and this whole thing is the third copy of f2. This is the first copy of f1, this is the second copy of f1, and this whole thing is the third copy of f1. Now f0 is just going to add 1 to the input, so f0 of 3 is 4, f0 of 4 is 5, f0 of 5 is 6, so I get the 6 right there. Now f1 of 6, now the input has finally increased, and 1 is a successor ordinal, it's 0 plus 1, its predecessor is 0. So if I get 6 copies of f0, then that's going to be 6 plus 1, 6 number of times. This is kind of like the first video I made on the subject explaining how to evaluate all of these. So, in other words, this f1 expands out into 6 number of f0s, which all applied to the 6 takes us up to 12. So f1 just doubles things, so f1 of 12 is 24. And then f2 of 24 is going to be 24 times 2 to the 24. And then f2 of that is going to be 24 times 2 to the 24 times 2 to the 24 times 2 to the 24, which is approximately 10 to the 10 to the 9, 10 to the power of a billion. It's got about a billion digits in it, very, very, very roughly, because the specifics don't really matter that much. We're just going to abbreviate this whole thing with capital A. Let us zoom out again. So f omega squared of 3, if we expand it out, is all of this. And this capital A right here is f3 of 3. And I'm going to come back to this and just kind of comment on what's going on here. But first, let's just calculate this little part right here to kind of see how big we're getting. Alright, we got our limit ordinal here. We'll go ahead and plug A into it, quote unquote. So we have to go to the 8th element of the fundamental sequence associated with omega. Well, this is the 0th element, 1st element, 2nd element. Oh, okay, this is the 8th element. So we're going to go ahead and replace omega with this capital A. So now we have f sub A of A. Well, A is just a natural number. It's a successor ordinal. So we're going to go ahead and subtract 1 from it, like so. But in the process, we need to repeat the function capital A number of times. So now I have a number of copies of f sub A minus 1, all applied to the input A. Now, recall that A has about a billion digits, so I have a number with about a billion digits, number of copies of F, and these power levels, so to speak, are also about a billion digits. I only just subtracted 1. So now the next step would be to expand this out into F sub A minus 2 with A copies of that, and then you would go to the very end A minus 2 and expand that out into A minus 3's A number of copies of those. It's going to take a really long time before you finally get to a bunch of F sub zeros, at which point you're going to be increasing the size of the input, meaning that once you finally reach, like, an F sub 1, now you have a, 2A, and so you're going to get way more copies of F sub 0, and it keeps going on and on like that. So what is really going on here? So what's going on here is that we're using a lot of recursion to make some really big numbers. For example, this part right here is already bigger than Graham's number, right? So the way I like to think about the calculation is, like, you're in the calculation, you're trying to push leftwards, right? you're like trying to push leftwards, and as you're pushing leftwards, the input is getting bigger and bigger. And then when that larger input rams into one of these more powerful functions, it leads to all this expansion, right? So, like, when this number greater than Graham's number rams into this f omega plus 1, you're gonna get more than Graham's number copies of f omega. So it's like exploding rightwards, right? It's like push, 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 and then it's like pushing you rightwards, and then you're trying to push leftwards, but as you're pushing leftwards, the input is growing bigger. It's like push, 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 and then it's getting bigger and bigger. and then finally, like, you're like pushing, and then it's like push, push, and then and then it's like push, 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 and then finally you get up to the F omega times 2. You got something way bigger than Graham's number now, and then suddenly it turns into an F omega times something way bigger than Graham's number, which turns into an F omega times something way bigger than Graham's number minus 1, with a plus 1 at the end, which is going to expand out, and it's like push, push, and you're like, oh, you're trying to push back, and it's like this weird tug-of-war, and then finally you get up to the F omega times 2 plus 2. And then you think, oh man, I finally made it through all of that. I'm almost done. I just got one more to go. But you've really only just started. Because all of this was nothing compared to what's going to happen when you run into this one. Most of the work is going to be done with this one. You're less than 1 Graham's number if done. Way less than that, in fact. As much less... So that's the way I think about it, right? To just kind of like express, perhaps somewhat vigorously, kind of the way I think about how these calculations work, right? The bigger the input gets, and the more recursive the functions get, the more recursive the functions get, the bigger the input gets, but the bigger the input gets, the more recursions you're going through. So it's kind of like, let me know if you have any questions or comments or anything, and yeah, I'd like to hear it. Thank you for taking an interest in this, and yeah, take care.